It's 7:23. It's Wednesday. We're continuing with our Chemist Corner. Jesse, always on the edge here. What are you doing with fruit juice? How can you make that chemistry?
Well, it's all chemistry, right? Everything's chemicals.
Oh.
So I can make anything I want to. I could even make you chemistry if I wanted to.
Wow.
Yeah, well. You know.
That's power.
I know, it's magic. I know. So I thought I'd talk a little. We talked about the Coke bottle and the fact that it was a polymer, and I thought, well, this might be kind of neat to show something that you might encounter every day that's a polymer that you can eat. Okay. I mean, polymers are everywhere. Your DNA is a biopolymer, right. So...
Well, every once in a while I have a hankering for a good polymer, so how do we look that up?
So what I have here is some sodium alginate, and actually I had to use all my sodium alginate, so I can't show you the actual powder. But if you've ever used gelatin and you've seen the powder that it is...
Just Jell-O powder, kind of?
Yeah.
Yeah, okay.
Jell-O, some of it's an alginate, some of it is pectin, which comes from horse hooves or cow hooves or whatever. But anyway, they're kind of a biopolymer. And what I've done is I've dissolved some of the sodium alginate into, I just picked some fruit juice here, some apple, kiwi, strawberry. I thought you'd like that.
Flavor doesn't matter?
That's right. Well, I mean, it really doesn't. I mean, you can do it with any kind of juice that you want to. So I dissolved it in that. And what I have in the clear liquid that I have in here is actually, let me just get rid of some of that. The clear liquid I have in here is calcium chloride. Now, when I drop some of this, and I have some over here that I'd made, that I know works pretty good. If we can get a close-up on
we
this.
did. You moved
I'm sorry.
Right there.
Moved it out of the way.
Did I get it in the shot?
You get a close-up, and you can see as this drops in, it forms these little beads. So you can see them on the bottom. I don't know if you can see them actually.
Yeah, you can see them dropping down there.
Okay. So these forms these little spheres. And the reason why it does that is because the sodium alginate is, the sodium's a counterion. The alginate has actually it's a big, long polymer molecule. And it's got a positively charged end, it's got a negatively charged end. Okay? So it's kind of polar.
Like a magnet.
Like a magnet. Right. Exactly like a magnet. And when you drop it into a solution of calcium chloride, now this is food grade stuff, by the way, calcium chloride, calcium's got a big positive charge, right? 2+ positive charge. And when it drops in there, I hate to anthropomorphize elements, or molecules, but it wants to get away from it. So what it does is it closes in on itself and it forms a sphere. Okay.
It's like the chemical version of the fetal position.
Yeah, it's exactly. That's what it's doing. It's forming this little fetal position to try to put its negative charge on the outside and its positive charge on the inside.
Okay.
Because, positives repel, like charges repel. Right. So it tries to get its positive inside, and it forms these little spheres, and then we can take and strain it out, and we can strain these little spheres out. There we go. And
neatness doesn't really count in chemistry, does it?
No, it really doesn't. Okay. There we go.
That looks like tapioca.
It does, doesn't it? It kind of looks like caviar. If you do it with the right color of juice, you can make it look just like caviar. All right, so I got a little spoon here for you. So as you can see, it's kind of neat.
So right.
Go ahead and taste it.
Gelatinous.
It may be a little bit bland because you really need to add sugar a lot of times to these things.
Kind of boogery there.
It is a little boogery.
You know what? It's better than kale.
Well, there's a lot of things that are better than kale.
It's just thick juice.
It is thick juice, but it's fun.
Yeah.
But come on. You're at a party, and if you had this sitting out there.
Now, where would you get sodium alginate?
It's all food-grade stuff. You can order it online. You can order it from any, food supply place. Same thing with the calcium chloride. It's actually, calcium chloride is the same salt they put on rubber.
Now, can you do this with any soup or just anything that's liquid?
As far as I can tell, you can do it with just about anything. Well, I tried doing it with orange juice because I was gonna do some with orange juice and vodka because the alcohol, it doesn't react well with alcohol, but I thought with the orange juice, but it doesn't actually. The citric acid and alcohol seems to react poorly with this. Okay. So you might not everything you can do it with, but a lot of juices you can. And there's a lot of recipes actually I found online. For
something green for Halloween.
That's right. Yeah. You could do something green for Halloween. You can also make, if you submerge it and the tip like I did, and you kind of string it out, you can make worms. Yeah, it's kind of cool.
Nice.
So it's something you guys can play with for Halloween.
Do you actually do formulas and stuff in your classes, or you just do fun stuff all the time?
We just do fun stuff all the time, right?
That's
There's no learning going on.
I didn't like the formulas. I like the fun stuff.
No, but we use, just on a serious note, we actually use these demonstrations to enforce the concepts that we're trying to talk about in kind of an interesting way. Right.
Works.
So if we were talking about polymers, we'd do something.
All about the concept, and thank you for not bringing in a whiteboard and doing
little chalk
equations. Yeah. All right, Jesse Miller, Chemist Corner on the morning show. If you want to see a rebroadcast of this, some really neat ideas with the sodium alginate.
Sodium alginate.
Log on to IllinoisHomepage.net, and we'll be back with more of the morning show after this.